This is our task 2 of tutorial 12, and we are given a differential equation y prime is equal to 2 times y divided by x with initial condition y of 1 is equal to 2. Here x0 is equal to 1 and y0 is 2. Use the Numerical second order method midpoint rule to determine the approximation for y at x is equal to 1.4. Use a step size of h is equal to 0.1 for range of values of x from 1 to 1.4. So let's go ahead and start working on this here now. Our differential equation is 2 times y divided by x, and our initial condition is y of 1 is equal to 2. So this is our x0 and this is our y0, and for h we have step size 0.1. so our formula for the midpoint rule is yi plus 1 is equal to yi plus k2 times h. Now if we replace this with the values that we already know, we'll get here yi plus 1 is equal to yi plus k2 times h. So we know h is 0.1, so we would say 0.1 times k2. And now for k1 we have here the function at xi comma yi. So the function is actually written over here. So we have the function, this is our function here. So we'll rewrite it and we'll write that k1 is equal to, so we'll input the values of xi and yi instead of the y and x here. So we'll have 2 times yi divided by xi. And then we have for k2 the value of the function at the point xi plus half times h, comma yi plus half times k1 times h. So this now if you rewrite using the values that we already know, so we'll have here k2 will be equal to the function at this point. So I'll write the function itself, which is 2 times y divided by x. So y is this value here, this is y, and this is x, so x comma y. So our y is yi plus, now we know the value of h here, which is 1/2 times k1 times 0.1. that's the value of the h, divided by, we have here for x xi plus 1/2 times 0.1. Now this could be further made more easier to look into. So we have 2 times yi plus, when you multiply half times 0.1 you will get here 0.05 times k1 divided by xi plus half times 0.1 is 0.05. So that's k2 for us, our equation that we'll use to solve. k1 is here and yi plus 1 is here. So the 3 equations that we'll use from now on, maybe I'll copy them to the other page so it's more visible and we're working. So this is our y here, and then for k1 is what we have. And then for K2, we have these values here. Okay. So this looks a bit above. Let's bring it down here. And so okay. So this is for y, for K1, and for K2, our equations. Now, if we start working for, we have here I values, and then xi, K1, K2, and yi. So when I is equal to 0, it's given to us that x0 is 1 and y0 is 2. Now, for I is equal to 1, x1 is 1 plus xi plus h, so 1 plus 0.1, which will be 1.1 here. K1, the formula is 2 times, we have yi, which is y0 divided by x0. So we have 2 times y0 is 2 here, divided by x0 is 1. So that would give us the value 4. And for K2, we have here 2 times y0 plus 0.05 times K1, which is 4. Divided by x0 plus 0.05. So we can write that as y0 is 2 plus 0.05 times 4 divided by x0 is 1 plus 0.05. And if you solve that, you will get the value as 4.190. So I am taking the values in this question here up to 3 decimal points, and then for yi, now at y1 we can say, so this is one work, and now we are doing for the second one, which is we'll have here for y1. Now we'll have y0 plus 0.1 times K2, and K2 value is 4.190 here. So y0 is 2 plus 0.1 times 4.190, which is equal to 2.419 up to 3 decimal places. So that's done for I is equal to 1. Now we'll work with I is equal to 2. So we have here x of 2 is 1.1 plus h, which is 0.1. So we have here 1.2. And here we have 2 times y1 divided by x1. So we have here 2 times y1 is, as you can see over here, we have y1 is 2.419. 2.419 divided by x1, which is 1.1. So that gives us 4.398. And for K2, we'll have 2 times y1 plus 0.05 times K1, which is point, or I'll write the value next time. So here I'll just write it as Q1 divided by, we have x0, x1 now, plus 0.05. So this is equal to 2 times y1, which is 2.419, plus 0.05 times q1, that's 4.398, divided by x1, which is 1.1 plus 0.05. So when you solve this one here, you will get the value as 4.589. Now for this one here, you will have y1 plus 0.1 times k2. So here our k2 value is 4.589, and that will give us, so let me write the whole equation here again. So y1 is 2.419, plus we have 0.1 times, have here 4.589, and that will be equal to 2.878. I'll go ahead and calculate for I is equal to 3. So maybe I'll just write again here. So this is I, xi, k1, k2, and yi. So I is equal to 2, I is equal to, that will be 3, and x3 will be x2, that's 1.2 plus h, which is 1.3, and for q1 we have 2 times y2 divided by x2. So we have 2 times y2 is 2.878 divided by x2 is 1.2, and this gives us the value 4.797. For q2 we have 2 times y2. So here let's look at the formula again. So we have yi. So we'll take now y2 plus 0.05 times k1, y2 plus 0.05 times k1 divided by, we have here x2 plus 0.05. So we'll have 2 times y2 is 2.878 plus 0.05 times k1, which is 4.797, divided by x2, which is 1.2 plus 0.05 here, and that gives us the value 4.989. So for y3 now, we have y2 plus k2 times h. y2 is 2.878 plus k2 is 4.989 times 0.1, and that gives us the answer as 3.377 up to 3 decimal places. Now for I is equal to 4, we have xi is 1.4, 1.3 plus 0.1, which is 1.4. And then here for k1, we have 2 times y3 divided by x3, which is equal to 2 times y3, value is 3.377 divided by x3, that's 1.3. So this one here is equal to 5.195. And then we have 2 times y3 plus 0.05 times k1 divided by x3 plus 0.05. So that will be 2 times y3, which is 3.377 plus 0.05 times k1. So that's 5.195 here, divided by x3, that's 1.3 plus 0.05. So the whole thing, when you solve or calculate, you will get the value as 5.388 here. And then we have y3 plus k2 times h. And so y3 is 3.377 plus k2 is 5.388 here times 0.1. So that will be equal to 3.916 up to 3 decimal places. So we can say that y at 1.4 x value is approximately equal to 3.916. That's the end of task 2.